Welcome to the Azure Machine Learning Service series of presentations, and this is part one, the introduction, the overview. So this gives you the background, so you'll be prepared to continue with the other presentations. Now, the Azure Machine Learning Service is a big topic and has many features, and so this is a great place to start because I'm going to really be mostly conceptual. I will show you how to create the workspace for Azure Machine Learning Service in Azure, but other than that, it's going to be more conceptual. But I think you really need to see this before you can get into the other content, and it's something that I actually created because I didn't see something that provided this kind of depth of conceptual framework, so I hope you like it. My name is Brian Kafferke, and I'm a Data and AI Solutions Enabler at Microsoft. Let's jump in, and I will call attention on the slide. There's two little Python icons as part of the Azure Machine Learning. So the cloud shows that it's Azure. The little Azure ML icon shows that it's machine learning, but it is very specific at this point to Python. So a lot of what I'm going to talk about, the framework and the structure, is not so much Python, but the interface that we use are Python modules. So if you're doing data science with Python, then you're definitely going to be very interested in this. So where are we going in this presentation? We'll start by creating a sort of baseline, which is the data science process. And that's going to become the sort of framework for the future presentations as well, because the Azure Machine Learning Service is all about helping to augment, automate, and scale the data science process. So it's all about providing tools and services to help there. Then we'll talk about what the Azure Machine Learning Service is not. And I want to talk about that because there is some confusion with similar names like Azure Machine Learning Studio, Azure Machine Learning Server, and even the just generic term Azure Machine Learning Services, which seems to imply a bunch of different services. So yeah, there's a little bit of confusion, and I've had a lot of customers ask about that. So I'm going to clarify that up front, and by the end of this presentation, you will know exactly what this is. And that's where we get into, after we know what it's not, we'll talk about more about what it is. And then we're going to tie the Azure Machine Learning Service back to the data science pipeline, because that's what it's all about. And when I overlay it, you'll be able to see exactly where you would use it in the data science process. And finally, I'm going to really pin it down like, okay, but specifically, where would I use it and why? So there's a lot of that in here. It's got some amazing features, and I think it's one of the undersung and underappreciated services in Azure. It's amazing. I got excited about Databricks, and I started singing Databricks praises. This is sort of my next thing because I'm really fascinated with this service, and I think it offers a great deal of functionality for customers. And at the end of the day, this service, like so many in Azure, is about empowering everyone on the planet to use advanced technology to solve problems. So let's avoid the confusion. There is a product Microsoft has, a service called Azure Machine Learning Studio. It's a great product. It's a great way to learn about machine learning. It's a visual drag and drop environment where you right mouse click, you set properties, you drag things around to connect them, and it's really cool. It's fascinating. It's a great service, but this is not that. That is portal based, and it's really kind of a standalone, self-contained environment that lets you do everything right there. It can be used for really end-to-end data science solutions. Generally, smaller solutions would be suited for Azure Machine Learning Studio, especially where you have sort of what they call citizen data scientists that don't really know how to use Python or R. Perfect place to start. This is not that. And the other thing I want to avoid confusion is something called Machine Learning Server, which typically is aligned with SQL Server Machine Learning Server. So a little background on what that is. 2016 SQL Server, release SQL Server 2016, Microsoft purchased a company called Revolution Analytics, and Revolution Analytics had a product called R Server. And R Server essentially did for the R language what SQL Server does for SQL. It scaled up R scripts to scale up to a single server using all the core available, being able to page memory in and out, being able to do parallel processing, and so it scaled up really well. It did that by using replacements for the open source functions. Open source Python and R functions don't use parallel processing by default. Will crash when you fill up memory, like data frames, if you know what those are. Those basically in-memory tables. There's no ability to page in or out or all these things. And so open source code does not scale well. That's the kind of surprise I think data scientists hit pretty quickly. It's good for small things, but as soon as you get big, you have problems and you get more data. The machine learning server, our server, does scale. It does really well. It can scale nicely, just like SQL Server. So when our server was purchased, the first thing Microsoft did was integrate it with SQL Server, and that was the 2016 release, and they called it our server still. And it's integrated with SQL Server so that you can not have to export data out of SQL Server to work with it. It can share the data space. They're technically separate services and have their own operations, but it's integrated so seamlessly that you don't actually see any of that. The bottom line with it is you get all the advantages of SQL Server, including encryption and security, and the feature of not having to export data, which of course is itself a security risk. And you get it all within SQL Server. So you can write stored procedures with our code in 2016. Now it got renamed to Machine Learning Server, and causing, I think, some confusion with my topic today, because it then became our server to Machine Learning Server. So then people said, what happened to our server? Well, it just got renamed. Why? Because in 2017 SQL Server, they added Python support, and they added commercial, non-open source libraries, which extend and do all this scale up functionality within SQL Server. Now there are some other flavors, because this again came from Revolutionary Analytics, which supported integration with Teradata and also ran as a separate service on Linux. And you can also, on Azure, create an HD Insight instance which uses Machine Learning Server. So I can understand some confusion, which is why I want to say it's not the Azure Machine Learning Studio, which is the drag and drop, and this is not Machine Learning Server. Both really good products. I encourage you to go look at them and check them out. This is very different. As we'll see, the Machine Learning Service, Azure Machine Learning Service, is really designed to integrate and work with what you already have and not separately as these products really are. So let's step back a minute, and this is going to be the highest level at which I'm going to drill down into more detail to provide a sort of map as to how the Azure Machine Learning Service fits into what we're trying to do. And by the way, I forgot to tell you, I am, in honor of its Python focus, drinking out of my Python mug. I wish it was a little bigger mug. I like to drink more at a time. And I'm also wearing my Python shirt. I'm big on branding, so not surprisingly, right? So when we talk about this, again, I want to start with the data science process. And you can see some links at the bottom of this page. My slides I'll post in the link are all on GitHub, and as is any code I use. This won't really have any code to see, so we'll have code in the later presentations. It starts with this sort of cycle, and it's all interconnected. I would argue it really starts at the beginning. You could sort of break that last link because it really starts at defining the objective, the business objective. So I'm going to start with the use case that I hope to follow through all of the presentations to create consistency, and you can really see how pieces fit together. The use case is simple, so it may not get into other things, and maybe I'll dabble into complexity in terms of things like deep learning neural networks, which are really good models for doing things like image classifications and things. But I'm going to try to keep it simple so that we can see how this fits. So the use case I want to talk about is something where we have a data set really available, small data set, so it doesn't really show the scalability, but I'm not worried about that as much as conceptually following this through end to end. We're going to use a data set which is low birth weight data set. And the idea here, the problem I'm going to start with is, imagine you're a hospital and maybe a clinic, and you're trying to help improve healthcare and reduce costs associated with problems that occur in healthcare late on. So the idea is to identify risks early on. And the problem here is you want to identify high risk, low birth weight babies before they occur, or specifically when mothers go in for, say, their first check, and they're going to their doctor and checking on things to sort of predict early that this is a very high risk of a low birth weight, probably so you can do intervention kind of things. Maybe you check on them a little more often. Maybe you set more frequent appointments to touch base on things. Maybe you can put them in contact with assistance services, because maybe part of their high risk factors include things like not enough income to properly have nutrition needs met, etc. So the idea is intervention. And of course, there's also a financial component, because the later in the process you could have a baby that's low birth weight and requires a lot of intensive care and expensive maintenance and procedures. So again, it's a win-win if you can reduce the number of low birth weights. So that's the objective. We want to lower the number of low birth weights. Great. Well, okay, so the next step is you have to collect data. Now, predictive modeling is really using historical data to predict the future. There are other types of machine learning. I'm going to focus a little more on predictive modeling here. But in this case, we want to say, okay, historically, let's get data about the population specific to the case that we have. We don't want to have a population that's very different. We don't want to have, if we're looking, I'm in Boston, I wouldn't want to be looking at the population of low birth weights of mothers in China or something. It may not cross over that well. So I want something, a population that fits. And in that data, I'm going to use historical data. Data where I know if the birth weight was low or not, and I have a lot of other information like age, demographics, health issues, biometrics like blood pressure, etc. And I'm assuming, and this is where the sort of hypothesis begins at the beginning, I'm hoping at least, that if I know a lot of information about the situation in which a low birth weight occurred and in which they did not occur, then I can use that to create a model that can predict that before it happens. So I could use the same information going in that I know, age, blood pressure, any kind of comorbidities, etc. And I can feed that in and it can say, yeah, based on this, you're likely to have a low birth weight. The one thing to keep in mind about predictive models is at the end, it goes through all these algorithms and it's creating statistical relationships. It's doing a probability calculation, and then it creates a little probability engine, a little mini calculator, which is a function, which then based on the data you give it can give you the answer you want. In this case, yes or no, it's going to be a low birth weight. So we got to collect the data. We need historical data on birth weights. Then we prepare the data, and not going to get into details at this point, but you need to do some cleaning up. You need to get rid of different pieces. We'll look a little more at that, and you need to structure the data in a specific way that it can be used to train a model, which is where it creates that predictability. It creates the calculations, the probability connections, or statistical, how do I say this? It basically just creates the relationships and knows how to get from the input data to the answer of yes or no. So it does that using statistical probability calculations, and that's the training process. The analyze and evaluates the other step. Now, once you have different models, you try different approaches, then you say, how are they doing? And you use data which you didn't feed to the model, which they call the test data set, and you put it through to say, well, this is the model. How did it do based on comparing it to real historical data? And based on that, if you get like 100%, you're probably doing a little too well to trust it. They call that overtraining sometimes, at very high risk of 100%. But if you can get around the 90% or even 80%, well, you're way ahead of guessing. And takeaway, machine learning and predictive models is not about actually predicting this will happen. It's not going to pick the lottery number for you, etc. It's really about getting beyond what we could get with just guessing. And the more we can get sort of above that level of guessing to something that is highly probable, that's as good as it gets. And that there's a lot of factors that go into that, but that's ultimately what it's going to do. If you can predict and get a big leg up, say go from guessing, say 50% to getting a 90%, that's good. And you will have some errors. That's guaranteed. There's not always going to be spot on and pick everything, but it's going to help improve the situation. So in something like this, we may be able to reduce by, say, 60% the number of low birth weight babies. That's a huge accomplishment. So, but it's not magic, so I got to point that out. Then once we've evaluated, we've picked our model, we said this is good, we've trained it, we do what's called publishing, which is where we put it somewhere where it can be called by some application, maybe a web app, a mobile app, maybe in some sort of on-premise patient admittance application could call out and say, okay, I've got all this data on this person, what's the risk? That once you put that now available, then you want to kind of monitor the process, see how is the model performing, track it, how many people are using it, is it being used, etc. And then it kind of iterates around. But chances are, if you're doing well, then you'll define a new objective and stop this cycle again. Let's go a little deeper and talk a little more about specifics. And this is where later on you'll see we're going to map those specifics to the Azure Machine Learning Service. I got to remind myself of the name. So we start by defining a question. So let's think of the question, will this baby have a low birth weight? That's really what we're trying to determine. Now we know what we want to be able to predict. What data do we need to answer that question? Now I'm kind of keeping it simple. We're going to use a very small data set to do this. But ideally, you'd have a large data set of a population of expectant mothers historically and whether or not they had a low birth weight baby, and you set some metric on that. But basically, once you know that, you have your data to work from. Now, as an exploratory data analysis process, you want to look at the population of data. You want to look at ranges of values, do box plots, do all kinds of frequency distributions, etc. You want to get a feel for your data, and once you do, you get a sense of like what parts of this may make sense. Does the age have an effect? What are the range of values that we get for things? Once you get sort of a good feel for the data, and ideally you have a domain expert, somebody who knows a lot about healthcare, maybe a lot about pregnancies and in that domain particularly, and can really help guide what we need for input. But now we prepare the input data to be used. And part of that is removing nulls, outliers. If you see somebody is 358 years old, I'm guessing there's an error in the data. You may see things though that are like high blood pressures that look are hard to believe. And so you've got to really figure out what to do with those. And in a case like this, maybe you want to be able to, you have a separate row of data for each instance of a mother and birth weights. It might be the same mother spread over time. She had a baby at one point in time, low birth weight, another baby later, low birth weight. So you might want to aggregate that, right? Count out how many in one person, consolidated down to a single instance of an expectant mother, and then say previous low birth weights. And that, I'm guessing, would have a pretty high correlation to predicting whether or not they're going to have another low birth weight baby. But I could be wrong, but I would guess that, and that's why you go into, that's what's called feature selection and training, feature creation. So experiment then with various models means there are a lot of different ways that this prediction can take place, or where the model can be created, and they're called different types of models that can be used. So for instance here, some of the choices we have a number of classification models we could use. We have logistic models. We can even use a deep learning neural network, DNN, which is very trendy right now, and they tend to have really good results. There's a lot of factors that go into what model to choose, as we'll see, but that's where we start. And so we're going to play around with these, and the idea is evaluate which models perform better, which ones are doing a better job predicting. Once we know the model, we've trained the model that works the best, then we pick that model. And in this case, we'll say it's a KNN classification model. And finally, we've got it, we're ready, it's trained, and we're going to deploy the model. And that does leave the question, where do we deploy it? This is one of the non-trivial questions in my mind, because you have to have a server somewhere, some hardware, an environment that you can deploy this model to with all of its dependencies so that it can be used and called externally, more than likely, to score data. So how do we secure that? How do we acquire the hardware for it? How do we scale it up and down? Those are a lot of issues. So we have the choice of on-premise or cloud. Hint, hint, I'm thinking cloud would be better, but we'll see that when we get to it. So in a nutshell, we're going to dig down a little deeper, but I want to give you the high-level picture here. The Azure Machine Learning Service provides tools to scale and automate training, deployment, and monitoring of machine learning models easily and seamlessly. That's a tall order, because as anyone in data science knows, there's a lot of messy pieces. It's come along so fast that it has not been worked out in the kind of, smooth processes that you tend to see around DevOps and, say, mobile app deployments and things. Machine learning is just constantly changing, and it's really been amazing in the last couple of years just to see how much progress has been made around getting a handle around it. But in my mind, it's still pretty immature. It's still evolving quickly, and the Azure Machine Learning Service is a huge step forward. So let's take a look. I want to get one key takeaway, and this is not something obvious when you first start to look at the Azure Machine Learning Service. At its core, what is the key to what technology is being leveraged here? And ultimately, we're bringing the power of containerization and automation to data science. So if you've heard of things like Docker and Docker containers and Kubernetes and all these things, that's what we're talking about here. Very big in DevOps, very big in any kind of web applications and things. Gives us a lot of scalability, configurability, just a huge amount of scale and flexibility. And Microsoft is trying to bring that power to machine learning. And it's going to do it with very specifically tailored services that leverage those technologies, as we'll see. So it's going to help us in areas of model training, deployment, model management, and more. So we'll take a look at this. But to back up, just in case you don't know what containers are, fear not. I'm going to try to give you a mental picture of what they are. You don't have to be an expert. I'll say in a nutshell, you have a program you want to run, and you have to have an environment in which you can run that program, and a container is designed to do that, to support the execution of an application or program with minimal overhead. Okay, so if we look at the idea here, you've probably seen VMs. VMs are similar, but VMs have to emulate all the hardware of an environment. They have to emulate all of the operating systems, so they have a lot of overhead. Containers are more lightweight. So the idea is it is like a container. It's like a little box, and we're going to put in that box our application. Now the operating system, when you set a bunch of containers up, they can share, multiple containers can share the operating system. So you don't have to create an entire copy, version and all the patches that go with it, of an operating system for each app, for each container, which saves us a lot of overhead and allows for a lot easier management of the containers. The other thing it has is it has a container management process or engine, and that's called a hypervisor. So Kubernetes is such a thing. It's a hypervisor. And so you can see here that the hypervisor will manage those containers for you. The app and the binaries are where the containers reside. And this is really where the power comes in. So you have, I'll say Django. Django has very specific versions in Python. You have to have, are you using Python 2 or 3.x? What versions of, if are you using ORM, so you're using the built-in one, or maybe using something like SQL Alchemy. So all these libraries and scikit-learn and all these different tools we use, pandas, they can be very version specific, and if you pick the wrong one and deploy it, you can break your code. They are not always backward compatible. You may be locked down in a previous version. Maybe you've got Python 2.4 or something that you're maintaining things on in libraries specific to that. The nice thing about containers is you can create all those dependencies. If you've used Python virtual environments, this is sort of that on steroids, I think, because it's sort of packaging that virtual environment and just lifting it, placing it into a box that can be executed, an application space, full environment, all you need to execute your code. Now, it's great with models because you might have a model that you want to deploy. This is the easiest place to think about deployment, but it can also be used for training models. But imagine you've got this great model. We'll say, in this case, the ability to predict a low birth weight baby. And you start your initial deployment, and you're doing a low scale. It's a single hospital. And so you're getting maybe 1,000 calls for this model a day. People go in, they get checked into the clinic, and boom, it does a hit and says yes or no. So you only have one little container, and it's fine. Suddenly, you have a bunch of hospitals. Say it's a network, and you want to open up to 10 hospitals, and then let's say 50 hospitals. Now you've got a scale. Well, the nice thing about containers is you can start with one container and say, oh wow, it's getting a lot of load. Better create a few more containers, and it can distribute that load of calling the container to score a model. And you might say, geez, I need more, 100, whatever. So containers, if you're getting the idea that really ideal for cloud, you're getting it, yeah. You could do this on-premise, as long as you have the resources, the physical service to support having the containers, etc. But obviously, with a cloud where you've got pretty much infinite resources, gives you really a lot of flexibility. Takeaway, though, a container is an environment space where you can execute your program. That's it in a nutshell. I hope that helps. So let's jump in. That's the application. So let's get back to the Azure Machine Learning Service. And I want to drive this point home. Data science meets containerization. Automation too, but really the containerization piece of this is very key to appreciating what this service is doing for you. So let's talk about why would we use the Azure Machine Learning Service. Well, first of all, I've talked about containers and all that stuff. And personally, I do not find using containers trivial or simple. They're great, they're cool, but if I had to go on my own machine and start creating a bunch of containers, say locally, I find it a little bit confusing, especially when I've got different libraries I want to have and versions of Python and different pieces to make sure I have all the pieces, manage those environments. And imagine if I was doing this with 100 or 50 different projects that have different requirements. I don't find it trivial. However, with the Azure Machine Learning Service, it is trivial, and all those complexities are hidden from you. So I think that's really cool. Now, the goal of this whole thing is making things faster, more efficient, more accurate. So faster turnaround, better results, automation, scalability is all this good stuff, and that's the other thing. And we'll talk about the ML pipeline, the machine learning pipeline, and that's key to this as well. One of my favorite things about this, and if you've heard of something called the Machine Learning Workbench, that has actually been deprecated because the Machine Learning Service was, I would say, is an evolution of that. And what Microsoft realized was people really want to use the tools they have. They've already got pipelines. They already have the IDEs they like, etc. And so the ML Workbench was perceived by some customers, I think, as being too restrictive and making you sort of adopt a different way. The beauty of the machine learning service is it doesn't do that. You can add any of these services, any one of them. You don't have to pick up all of them. You don't have to say, if I use any, I got to use all. That's not how it works. You can pick and choose anything you want, and you can add it in or remove it whenever you want, which is great. So, and you can do it anywhere in the process. So use only the services you need when you want them and pull them out. It's really like a couple lines of code here and there that you can just say, okay, take out that line of code. It can even be used to do things right on your own client machine and locally without using the services with the same sort of structure and code with these libraries. So again, it's the flexibility. You do things your way using your own IDE, PyCharm, Jupyter Notebooks. I like Jupyter Notebooks, but PyCharm, VS Code is good, whatever, and it doesn't care. This is, again, Microsoft's evolving, and this is a great thing to say, use open source, do what you want. We're not trying to control it, and this is a service that really, truly does that. So let's step in a little bit more. What are the challenges? So I look at machine learning, and I look at anything, and I say, where are my headaches? Where are my challenges? I just kind of go. And when you do consulting or analysis, you're always looking for those pain points. How much data do you have? Is it structured? Is it disparate? Do you have 50 different sources for the same for data that you've got to consolidate? So you're looking for the pain points. And the Azure ML Service is designed to help you with those pain points. So let's look at some of the challenging pain points in the data science process. First question we have is, what features will help me predict the answer? So I've got maybe, in some cases, this is a simple one we're using for the low birth weight because I don't have much data to work with to show you. But you could have 1,000 columns of data. What's applicable? What is relevant? Some columns may seem to call out at you age and blood pressure, etc. But there are a lot of other things that you may just not even think of that could be very important and useful. Picking out those features that will help predict the answer is not trivial. So that's one question. How do we scale this training of it? So again, I might start with a small data set. I think as a data scientist, I like to work locally, kind of get a feel for things. But then I realize, okay, I'm only working with 100, 200 rows just to get the feel of things. Now I want to scale it up to maybe a million or a billion rows of data, or even unstructured, say, images. How do I do that? So that's a challenge. How do you know which model to use? So this is the number one question I get whenever I present machine learning to people who are just kind of getting into it, especially. There's hundreds, if not thousands, of different models with different flavors, and open source and proprietary and all kinds of stuff. Deep learning neural network models, a whole suite there, and all kinds, and just competition everywhere on all these options. So it is not trivial. So it's a challenge to figure out what model is the best to use and what makes sense. And there's a thing in a model called hyperparameters. Hyperparameters are parameters of a model that cannot be learned by the machine learning training process itself. So they're things you need to pass into the model building process, and you really kind of generally hard code it, but there are guidelines data scientists use to sort of narrow down the best values for these hyperparameters. But an example I think of, and I think this is a good example of hyperparameter, which is when I think of like the KNN classification model, for instance, it's a nearest neighbor thing. So what happens in that model is it creates a sort of cross intersection, a multidimensional picture, if you think of multidimensional sort of data sets, where it intersects all the different properties of what you're looking at. So imagine if you have an animal, right? Like you're trying to classify a picture of an animal, or we'll say attributes of an animal, and it's some have been in the history with whiskers and size and weight classified as cats. Other ones are classified as dogs. You go in and say, well, what is this? It's got whiskers, but it weighs this much weight, etc. And what the KNN will do is it plots it a point. If you can picture intersecting on different dimensions, 2 dimensions easier, like think battleship, or is it close to your ship? Then it says, okay, which one is it closest to? So you, in that particular model, you can say, look at the closest single one. So whatever the closest one is, it says yes or not. It's a cat because the closest point would be a cat. Or you could say, look at the closest 5. So the closest 3 out of 5 are actually not a cat, but they're a dog. But the closest one would be a cat. But since 3 of the 5 are actually a dog, it's going to come back and say it's a dog. So that's a hyperparameter because it's controlling how the model actually is going to give you a result. Which one's going to work better? I don't know, right? I mean, maybe this closest one is best. Maybe 2 is best. So I could say 1, 2, 3, 4. this is a case where it's a challenge to know what to set your hyperparameter values to. How do I manage all my models? This is just a problem across the board in data science. In the data science world, we just have not reached that DevOps coolness. We don't like to talk about it. It's not a pretty picture. DevOps is just so cool because it's like everything's just automated. It flows through. I don't work in DevOps with these mobile apps, but they sure look like they have their act together. Not so in the data science world, but we'll see later. There's some cool stuff here I can talk about there. How do you deploy a model securely, yet easily accessible? So ideally like a REST API, right? Something anyone can call, but at the same time you secure it with credentials, etc. That's a real big challenge. It's one of the biggest concerns when I get really excited about Databricks, right? But deploying a model is different than training. Databricks is awesome for training a model, but here's the kicker. When you train a model, you're oftentimes dealing with massive data because you have to give all this history so it can figure out how to create that predictive program. The bottom line, though, is that little predictive program is a very lightweight program. It's a function, right? It wrote code for you, basically. If you think about it as a code generator, it's kind of what it is. So it wrote a little code for you, a little program that has all the statistical probability measures, et cetera, based on the type of algorithm you wanted it to use. And now you've got this little lightweight program. So imagine you have, like, I'll say a 20K program that you need to run. All it needs for input data is the exact columns that drive this, the features. Do you really want to run that on a Spark cluster with 100 nodes? I mean, that's an awful lot of weight, right? That's a lot of overhead to incur. Not to mention, you're going to either start up the cluster or you're going to have to keep it running. Wouldn't it be nice if you could just take that and deploy it onto a VM or some, something, container? Hint, right, where we're going. But wouldn't it be nice if you could just put it out somewhere where it doesn't consume a lot of resources, it just has what it needs and just is used for scoring? So the data science process can very much separate the training of model from where it's consumed and where it gets deployed. And that's a really key concept as well. These are all really challenging parts. And finally, we'll see this whole process of getting data and turning it into trained models and all that stuff. And how do we automate that? Like, again, we have these things that have, in other areas of the IT world, very streamlined, but we haven't gotten there yet in machine learning. So we'll talk about that. So when we talk about the machine learning pipeline, which we'll get into a little bit more later, we saw the steps of, asking the questions and getting into building this model. The sort of core concepts, the areas that really we're concerned with when we talk about this sort of pipeline is we've sort of done the data analysis, exploratory data analysis. We figured out the features that we want to use, etc. So now we basically are going to be on a sort of regular basis. We're going to have a job of some type. Pulls in data, we'll say like patient data, in this case birth rate data that's getting refreshed, and it's going to extract and pull the data in, and it does a bunch of things, normalization, they call it transformation, so it may have to convert columns, clean up things, drops, nulls, etc., validate data, and then the featurization is where it will actually pull the columns out that you need. And there's a bunch of things you can't usually take raw data columns and feed them into a model. You often have to take columns and convert them into what they call categorical variables. In R, they would call them factors, so that kind of thing. And then you can go into the next step, building and training models and deploying and predicting. And that's the area where ML services really helps. You can arguably use, in that prepare data step, you could use ML services, but I would argue where I find the real bang for the buck is in this other part. Also the ability to automate the entire pipeline, so I should point that out. But really the value that I'm going to focus on a lot here is the ML services, where it helps you build and train. Hyperparameter tuning, it provides services to select models for us. It will automatically test the models out and compare them and validate them. So you might have 100 models. It will run it concurrently. So a lot of great services there. And finally, it can help us by deploying the model and providing batch scoring, etc. So that's first takeaway here is kind of in your mind, get sort of where does the ML services really come into play to help you, and it's sort of where I've highlighted here. So let's go to this picture of defining the question again. In the define the question, we've got these steps. So we've got, I had to remind myself of the slide. We have the define the questions. What do you need to get the answer to the question? Prepare the data. And that's the previous step on that slide. The Azure Machine Learning experiment part will help us with experimenting with various models and picking the best model. And when we want to deploy, there's a whole deployment service within it that helps us with deployment. Now, the experimentation has some nice features. We also get along the entire way a whole tracking, auditing, reporting, analysis piece that is really great. So it helps us manage it. So it's kind of bringing that sort of DevOps functionality into this with our models. And we get some extra really value-added features. So with the automated ML, or they call auto ML, and notice I put little dumbbells here because I see that as doing some of the heavy lifting for us. There's kind of some grueling work here, figuring out what hyperparameters should be, and you can just let it go through all the work of doing that. Data scientists can do that. They know how to set ranges and pass it in and do all that stuff, but you can let auto ML take care of that and select the model. So depending on how much work you want to do, you can do it, or you can just let Azure do all the work for you and just say, just tell me the model I want, which is a great way to impress your boss and still get out on the golf course at 2 o'clock and they think you're amazing. And by the way, sweat a little bit, make it look like it was grueling. Don't just let them know it was this easy. That's half the fun, right? All right, so we kind of get that here. Let's take a little step forward now and talk a little more about the features that we have here. So we can easily extend existing machine learning pipelines to leverage the features. We get the automated feature selection. We can get automated hyperparameter tuning, automated model selection, integrated model management and logging. Meaning we can log things that are going on. Anything we want to log, there's actually features we can log it and track it. And then we also have the automated model deployment, complete with the REST API, which is pretty cool because, and there's features even here if you need to go to the IoT edge with it. There's services that let you push it to edge devices. I mean, a lot of cool stuff. And it's all accessible within Python modules provided to you. They call them SDKs. Azure Machine Learning SDK gives you these modules. So all it really is pip install, you get these modules. Tip for you, which I didn't want to forget, I highly recommend if you're going to use this, to use an Azure Data Science virtual machine. Create one of those, just go in there, really easy. I have a whole nother video on that. Go look at it if you want to look at those. And I say that because those come not only pre-installed with all of these tools, it gives you, you don't have to pip install anything. It's got the Python versions, it's got all this stuff, but it also has a bunch of scripts, demo scripts and stuff in Jupyter Notebooks right online, and it installs Anaconda on the Data Science VM. So you can go in and it's a great way to start because frankly, it can be a little hairy installing all the pieces you need to get it up and running, the modules and all the dependencies, because there's a lot of pieces for this. So I personally really like the Data Science VM. You might think they're expensive, but if you shut them off, I've kept it down to like a few bucks in like over a weekend, just playing with them, and then just turn them off. You can set on the virtual machine. You have to go back in after you create it, but you can go into the virtual machine and set it to, and I have I think on the Data Science VM when I talk about that, you can set it to automatically turn off at a certain time of day. Highly recommended, especially if you're just trying to learn things. But yeah, use those because it makes this process of learning how to use the Azure ML Service a lot easier. Okay. So let me step back for a minute. So we are now in the Azure portal. I'm gonna go to my dashboard. I like to organize things in my dashboard. And what I want to do first, I'll show you what it looks like. I already have an ML service created, but the first thing you will want to do, and this can be done in Python code. I can demo that later, but just as because I really just want to have a demo on this. I don't want it to be all theory. I'll go in here and I'm going to say create a resource. The first point though is I need sort of, everything is like boxes within boxes and with boxes. It's kind of like reminds me of those Russian dolls, with a doll and a doll and a doll. Because in Azure, when we're going to use things, typically we need to create some resource. In Azure Databricks, we create an Azure Databricks Workspace. Similarly, here we need to create an Azure Machine Learning Service Workspace. And if we go in here, we can just say the plus sign to create a resource, right? And then we can go into the category AI Machine Learning, or we can just type what we want. But in this case, it's a small enough subset. I can go right in here. So here's where you create your Data Science VM. Again, highly recommend. They're awesome. I love them. Great learning tool. The Azure Machine Learning Workspace is here. Just click it. And by the way, really take advantage. There's all kinds of places where there's links to tutorials, to documents. I'm amazed we're so eager to jump in, but we miss a lot of help available. But here I'm going to say, okay, I'm going to use the Azure ML BPC for my initials, 256, because I probably don't have that. I create a lot of stuff. I'm using my subscription pay-as-you-go. I'm going to create a new resource group. A resource group is a way to group things you create in Azure so they're sort of together, which means it's good for managing things. My favorite feature of it, which is why I'm going to do it here, is I can delete it and get rid of anything attached to this. Now the Azure ML Workspace, as well as many things in Azure, create a lot of things under the covers. But when you give it a resource group, whatever this creates will be part of that resource group. So if I delete it, it's all gone. I don't pay anything. So I always, for demo purposes, I always do this. So I'm going to say resource group. I like to start my resource groups with RG underscore so I can find my resource groups easily. And I'm going to just name it the same. So I'm going to Azure Machine Learning Service, MLS. Okay, I don't have the S there. And then I'm going to say 256. And just to be consistent here, I'm going to change this to Azure MLS so we're consistent. And oops, I lost my resource group here. So try it again. So it's the RG Azure MLS EPC 256. Okay. So that's going to create the new resource group. If you're in an existing organization, there may be rules about what you do, but if you can do that. Location, I'm going to pick the East US because I'm in Boston area, so it makes sense. But you want to pick the region. Hopefully it defaults to the right region for you. But if it doesn't, if you're in the West Coast, then you want to go with something West US or West US 2. There's a central one. There's ones for Asia. There's ones for Europe. So pick the one that's relevant for you. And then just say create. And that's it. That's the complexity. You'll see this little, you should see this bell start showing messages. See that? So the bell starts building things, and that kind of gives you messages. Now, to speed things up a bit so I don't have to wait, kind of like, like the baking show, I'm going to take it out of it. It's already baked and ready. I have one I created here because I do want to show you a few things in here. So typically with any resource in Azure, you go into the resource, and I pinned it to my dashboard, but you can search for whatever and just pick it, and you get what's called the overview pane or blade. And every time you drill down, they call it a blade. But notice you get exploring your machine learning service. You can get documentation here, a forum you can connect to, samples on GitHub, Azure Notebooks. Azure Notebooks are really cool too. And this is another way using Azure Notebooks. You can also use those as a way to use Azure ML Service if you want to experiment and learn. And I believe that comes with the Python things installed also so that you can use those. So another place you can do it. But I still like data science VMs. They're very cool. So explore, let's go into this for a minute because I want to show you, notice resource group, etc. Go in here. And we'll notice a few things. We can open Azure Notebooks here and get started. So that's cool. It's going to help us get a jump start. We can view experiments. So as we create we're trying different types of models. That's our experiments. And you can see all these things. So Microsoft's pretty good. This is actually relatively new, I think, at the bottom. So I like this a lot because we can see, okay, run and monitor experiments, register models. We get a perfect model. We say, this is what we want. It's like going to the registry of motor vehicles. You go and you say, okay, I have some junk cars and I'm not driving and they're, I don't know, buried in the backyard. I don't know. But this is the one I want to drive. That's what you do here. You're going to register your model. And that means that it's going to be tracked and you can have all kinds of management around it. Build images has to do with the containers. Won't get too much into all these things. But the key takeaway is you can define not only what you need as dependencies for your process, like what scikit-learn and Python versions, but you can also say, what do I want for hardware or virtual hardware? We'll say, I could use, for instance, if I'm doing a deep learning model, I could say use a GPU, which is a graphic processor, which is highly optimized for mathematical processing. It's going to go faster. So I can pick resources, memory. So I have that control at a granular level of what kind of power I want. Deploying models and creating a pipeline. So a pipeline is actually this end-to-end kind of. I think of a pipeline a little bit like an ETL process, but in this case, it's doing machine learning training, but it's ingesting data, going through the whole process, putting out the model, etc. And then you can go in here. So notice too, we have pipelines here. I don't have any pipelines yet, but we have pipelines here. We have compute. So this is kind of, let's just take a look at the sort of resources in Azure we're going to use, the CPUs, memory, etc. We have models, we have images, deployments, activities. So this is kind of your hub, if you will, the sort of touch point within Azure through the portal that you can see. Now the SDK, the modules from Python, give you abilities to query into this and see it. So if you're like a real Pythonic person, you just want to use Python, you can pretty much do everything within Python as well. I like to do pieces in the portal and then pieces from code. All right, so let me go back to my riveting slides. And we just saw this, so this slide just to kind of remind you, there's a lot more to the workspace, but you do need to have a workspace before you can do training of models and things like that. And you'll actually create like experiments within a workspace. So there's kind of a hierarchy of pieces here, and I'll talk about that more in future lectures. I don't know if I may have a slide here about that a little bit, but to give you a feel of the sort of workflow that goes on here, there's sort of the preparation, prepare your data. There's then your experimentation process, and you can see you build your model, and you build your model, use whatever IDE you like, but that's the idea there. And you really get into the Azure ML services when you start to kick in the training and testing of your model. And then once you get the good model you want, then you register your model. So now Azure says, okay, I know you want that. Now the key to registering the model is so that it also, now Azure's going to start to use that, says, okay, you registered your model, I need to track down what are the dependencies, what does it look like, and that goes into building an image. So it's kind of, now that I know you want to use this classification, KNN classification model, then I know you're going to use this version of scikit-learn, and you're using pandas or whatever you're using in here. So that goes into it, and finally it deploys a web service. So you can really automate the pipeline, and you get a lot of assistance here. So kind of getting into, now this slide, I admit it's a little bit of overhead. I was questioning whether I should even include it, but I like the idea. It shows you some of the pieces, so don't get overwhelmed. We will go through this in a more step-by-step process, but I hope it kind of helps also kind of get another way of sort of looking at the same thing. So in this case, you're showing a trained model on the left. You register the model, so this is more granular. You say, okay, this is the model I want. Now you have the registered model. You go in your code editor, and here's a really cool thing. When you want to deploy it, you don't have to actually sit there and sort of say, oh, it's a REST API, and it's going to take birth weight, it's going to take age, and it's going to take this feature and this feature. Instead, you just give it a scoring file, a scoring script that's designed to call, to basically use the model, and the Azure service will actually use that to infer what it needs to build for the REST API. So that's pretty cool, and what it needs for the entire service to be able to use it. So then it goes into the image registry, and from the image registry, it creates and registers the image. And the image is really that Docker container image. That's what they call them. So it knows all the things it needs to create a container. And then it can deploy it. And then you have cloud service, heavy edge, light edge. So there's all things you can do with how you deploy it and where. And then finally, this monitoring piece. So I haven't talked a lot about monitoring, but it's really key to having insights into it. Are people calling it? How much is it called? Is it running out of resources? So there's a lot of important aspects there. So this is a more sort of, once you've got a model trained, etc., you can kind of see into it, like pretty cool services here. So I'm going to go full circle and go back to the challenges that we talked about earlier, and then just kind of reference the touch points in the Azure Machine Learning Service that we'll look at more deeply in the future discussions. So we talked about what features will help your model predict an answer. So in other words, how do we determine those features to use in the model? So there's a service they call AutoML, which you can just call it and say, look, I don't know, here's 600 columns, Azure, tell me which of these columns I should use for this. And it will come back and say, these are the columns. And by the way, I tracked it and found out, not only do I know those are the columns, I know it because I've compared all these different runs that used other columns and they didn't score as well. How do you scale machine learning training? Well, here you can use a combination of the AutoML service and your own ability to configure the resources in Azure to be used. For instance, I mentioned GPU, so you can configure that so that it will get more or less resources depending on what, including even setting limits like, okay, I want you to pick a model, but don't run any longer than, or don't use any more than X resources. So it's really cool because you do have cost management. You can manage this well. A lot of customers always talk to me, in the sales side and say, well, that could get expensive. But I'm really kind of amazed because how expensive is it to have a data scientist spending a week, picking models and choosing hyperparameters? I think that's going to prove more costly. Human resources typically are more expensive than computing resources, but definitely turn the lights off when you're not using things. Always turn them off. Don't keep things running. You don't. The service is pretty good. Just delete things if you're not using them. If you have old models that you ran tests, experiments, you don't need them anymore, they weren't used, delete them. How do you know which model is best? Again, you can use the Auto Machine Learning Service model selection. It will tell you what model to use and what are the best values for hyperparameters. It will feature it, which is part of AutoML called Hyperdrive, and that will tell you the best hyperparameter values. How do I manage all my models? Again, this is a really powerful value-added part that's sort of ubiquitous around the rest of it. As you're building your pipelines and doing all these pieces, you can let Azure track the models, model versions, what are the images that go with this for deployment, all these pieces, who's using it, logging, custom logging and stuff. all provided as sort of just as part of the service. So it's kind of nice. It's almost like you forget it's there, but it could be almost, it probably is almost the most valuable part of the service itself. How do you deploy a model securely yet easily? There's the Azure Machine Learning Service deployment service. And how do I automate the machine learning pipeline? As we saw earlier, we can see that there's actually a whole pipeline piece in there. So we can create pipelines and schedule them and do all that as part of the service. So again, it's a massively powerful and wide-ranging service, which is why I think it's a bit overwhelming sometimes for customers to get their head around because there's so much offered here. So I hope I've clarified some of that. So let's step through what we've talked about. We took a look at the data science process, and we got the sense of, everywhere from what we're trying to solve the problem to all the steps of creating, training, and deploying models. We looked at what the Azure Machine Learning Service is not. If nothing else comes across, just know that it is not Azure ML Studio. That's a drag and drop GUI interface for doing machine learning training and deployment. Not that. And know that it is not Machine Learning Server. It's a very specific thing. Maybe they'll come up with some cool name. I don't know, so that it really stands out as a very distinct thing. We'll see. But we did talk about what it is. So we got into that, and it's really something that it's very interesting because it's just kind of there behind the scenes, and you use it as you want, and it takes care of a lot of work for you. But it doesn't really have a lot of GUI interfaces around it. It's meant to be something that you can ubiquitously use in your process and not have to do a lot of work around or change your existing workflow. The Azure Machine Learning Service and the data science pipelines, we talked a lot about how we can use all those features in a pipeline process, the data science process. And then we finally went back to the problems of doing machine learning data science, and then we showed how we could map that into the Azure Machine Learning Service. So I hope that explains a lot. I know there's a lot here. Watch the video again because I'm sure it's riveting, but I will do more on this. This is right up there with Databricks in terms of how fascinated I am and excited I am about something. When Microsoft hits something I'm really get excited about, you can't hide it. I get like, this is really awesome. I think that's spot on. I think it has an evolution process still ahead, so I won't say it's perfect and everything I ever wanted is there, but the features are just awesome. And I feel very strongly that Microsoft is going in the right direction with this. So I hope you like it. And if you like this presentation, like, share, subscribe. This is all for you guys out there. I can't contain my excitement about this stuff, so I hope you are too. Thank you. Take care.